Hello. Okay, so this is a continuation from the previous lesson. Okay, right now we are going just to do a quick recap. Okay, right. So what we have done so far is what we learned about displacement. Okay, displacement has the notation S. Okay, and then we also learned about velocity. Okay, velocity has the notation V. And what's so special about this that we have learned is that both of these notations or both of these quantities, they have directions involved. Okay, in so some ways, they are what we know as vectors. Yeah, I know we haven't learned vectors yet, but any quantity that has direction, of course, that is a magnitude. That means that it's a number. Okay, and it involves a direction that will be known as a vector. Okay, so we also know that to move, if you are given displacement and you want to get velocity, okay, all we need to do is to differentiate. Okay, you'll find ds dt. And I briefly talked about if you are given velocity and you need to find displacement, the function for displacement, you will have to integrate with respect to time. Okay, all these functions are with respect to time, so the time factor will be your one of the variables in the equation. Okay, so let's look at try 2 first. Here I'm going through some of the textbook questions, and for practice wise, you will do the execution. Okay, so let me just insert the image. Okay, so I have inserted the image from the question from try 2. All right, so here we have a particle moving in a straight line so that it displacement s meter from a fixed point O is given by s equals to 2t squared minus 18 when t is the time after passing a point P or point B on the line. So please take note, the condition is t is the time taken after passing a point B on the line. So only when the particle passes point B, then they start the timer. Okay, so and that's the equation given to us. So you're supposed to find the initial displacement of P. Now for initial displacement, okay, anything that's initial, we are looking at T equals to 0. Okay, so for part 1, at T equals to 0, my S would be 2 times 0 minus 18, and that would be negative 18 meters. Okay, so that is the initial displacement. Okay, the initial displacement, it will be negative 18 meters. So what does this mean? What does negative 18 mean? Okay, so it means that if I have a starting point O, okay, the fixed point that's marked O, and the object is moving, okay, when t equals to 0, I am at point B, and this is negative 18 meters away from O, okay, at t equals to 0. Okay, my S is negative 18 meters. Okay, so I'm on the left-hand side of my fixed point O. Okay, next. Okay, you're supposed to find the velocity of P when it passes O. Okay, so we are given displacement. So here, velocity, which would be ds dt. And this is given by 2 times 2t, and this is 4t. Okay, so that is the function for the velocity or the equation of the velocity. Okay, so you need to find when it passes O. Okay, when does it pass O? Okay, now the displacement is 0. Okay, at O, displacement is 0 because this S is from the fixed point O. Okay, so at O, your displacement is 0. So we need to find out what time does the particle pass through point O. Okay, so S equals to 0, we will sub it in. So we will have 2t squared minus 18 equals to 0. Then divide by 2, you will get 9 equals to 0. You get t equals to plus minus 3. Or you can just simply say that t will be equals to 3. Okay, because t must be greater than 0. It's a time. All right. And then we know that at 3 seconds, the particle will be at point O. And so now we're going to find the velocity. So v equals to 4 times 3. And this will give me 12 meters per second. Okay, it's in meters and seconds. Okay, please take note of the units. Meters, and right? These are the critical units that you need to be aware of. Okay, and then for part 3, we have shown that P never comes to rest after passing B. Okay, P, the particle does not come to rest after passing B. Okay, so come to rest means V equals to 0, velocity equals to 0. Okay, so for part 3, so there's no space here. I'm going to shift down a bit. So for part 3, right here, okay, when particles at rest, V equals to 0. So using your function of V, okay, you're going to solve V equals to 0. So 4t equals to 0, t is 0. Okay, so we can say that therefore the particle never, t does not, t never comes to rest after passing B. Okay, B is bad, B is 0. Okay, when t is 0 seconds. Okay, part 4. Find the average speed of P during the first 4 seconds. So please recall the average speed is total distance over total time. Okay, so they want the first 4 seconds. So if you look at the diagram, basically what happens is that the particle is just going this way. Okay, at t equals to 0. Okay, and we know that at point O, we know that this is t equals to 3 seconds. Okay, so they want the average speed. So what happens is that we have to calculate the total distance. Okay, and since the equation that's given us, the displacement equation starts at B, okay, we don't have to take into consideration when it turns on at any distance, other values. So for part 4, we know that at t equals to 4, okay, S would be 2 times 4 squared minus 18. Oh, hang on. No. Nope. Okay, just recap. The 4t squared, I'm just going to erase this. Nope, nope, nope. Okay, let's recap. S equals to 2t squared minus 18. And S is the displacement from O. Okay, so this one is a bit more confusing because you start your measurement from O. Okay, this is the start. S equals to 0. Okay, I'm just going to put on a diagram here. Okay, so you need to mark out at t equals to 4, what is the S value, so that we can calculate the total distance. Okay, so total distance between B and O. Okay, so we know that distance BO is 18 meters. Okay, so at t equals to 4 seconds, we know that 2 times 4 square minus 18. This gives me minus, okay, this gives me 14 meters. So what it means is if we are going back to the diagram, okay, this distance here is 14 meters. Okay, and we know that here is 18 meters. Okay, so what happens is the total distance traveled is 18 plus 14, which gives me 32 meters. Okay, and so therefore my average speed would be 32 over meters over 4 seconds. Okay, and this gives me 8 meters per second. Okay, that's your answer. 8 meters per second. Okay, so this is for try 2. All right, now because it is a pre-recorded lesson, you can always pause and go back to whichever section that you need. Okay, so I'm going to move on. Next is acceleration. Okay, so in EMath, we recall that acceleration is the rate of change of speed. Okay, so from the ST graph, okay, we look at the gradient. Okay, so here when it comes to AMF, all right, acceleration has the same meaning. Okay, the definition of acceleration doesn't change. All right, it is the rate of change of, instead of speed, we will say velocity because we are using velocity in kinematics. Okay, so it has second part, looking at the gradient, it will be dB dt. Okay, now what if you are given distance? Okay, if you are given the velocity. Now, if you are given displacement, what happens is that it will be d2s over dt squared. Okay, because just to write out the summary here, we know that if we have displacement to velocity, then we have acceleration. Okay, we know that from displacement to velocity, what we do is we find ds dt, first derivative. Okay, and then from velocity, if we move to acceleration, it's d v dt. Okay, so if you do the steps, okay, from displacement to velocity, you will differentiate once, and then from velocity to acceleration, you differentiate again. So you're actually doing two differentiations, right? So in short, from displacement, if you need to jump on the way to acceleration, okay, to find the function, it will be d2s over dt squared, right? So that's for acceleration. Basically, that's it. And likewise, if you are moving backwards from velocity, if you are going back to displacement, okay, I already talked about it. So S, to find displacement, you integrate with respect to t. Okay, so likewise with acceleration, if you want to get velocity, okay, you will have to integrate the acceleration function. Okay, there is no direct way, there is no notation. I think there is a notation for you to acceleration to displacement, but it's just integrate twice. Okay, so you have to integrate, find your constant, and then integrate again to find your second constant. Okay, so like your movement and acceleration, you will also get positive values, negative values, and zero. Okay, so there are meanings. So when acceleration is positive, okay, that means you get a greater than zero. What it means is that, okay, the object is speeding up, or we say that object is accelerating. Okay, means the speed is increasing. Okay, so okay, or we say that the object is, when acceleration is greater than zero, we say that object is accelerating, or in other words, speed is increasing. Okay, now when the acceleration is zero, okay, meaning a equals to zero, okay, what this means is that the object is at constant speed. Okay, so this is an important phrase to pick up. Okay, when the question says that the object is traveling at a constant speed, we immediately know that acceleration equals to zero. And then the third condition is when acceleration, okay, is negative. Okay, a is smaller than zero. Okay, though there is another word for this. Okay, this one is also known as deceleration. Okay, in this event, okay, we know that the object is slowing down. Okay, the speed is slowing down. Okay, so these are the main concepts that you will need to know for kinematics. All right. Last time they used to have a lot of other formulas, but now we are only required to know these three relationships and how they are related through either differentiation or integration. Okay, so let's look at the next question, which is try 3. So try 3, we have the particle traveling in a straight line such that t seconds after passing fixed point O, its displacement is given as such. Okay, you have t seconds after passing a fixed point O, and the displacement is this. Okay, so from here, there are certain important things that we know. Okay, when t equals to 0, we know that s is 0. Now, Let's check. It's not 0. Nope. Okay, wrong. Okay, so let's check. At t equals to, okay, so we have s equals to 6 minus 9 over 2 plus 3. Okay, at t equals to 0, we know that s would be 6 minus 9 over 3. Okay, here is 3 meters. All right, so let's check 9 divided by 3, then 6 minus 3. Okay, so we know that if you were to draw the line, okay, there's a fixed point O at t equals to 0, this particle is already moving away. Okay, it's already 3 meters away from the fixed point O. Okay, meaning to say your particle is starting from here. Okay, at a distance of 3 meters to the right of O. Okay, find the average velocity of P in the first 3 seconds. All right, so how do we find the average velocity of P? Okay, so we need to calculate what happens when this is average velocity. So this idea is an average speed. All right, so when t equals to 0, we know that, okay, so average velocity is the, so we use the correct term, total displacement over total time. Okay, so here, so at t equals to 0, now total distance, displacement, meaning we are looking at what is the displacement at t equals 0, what is the displacement at t equals 3, and then we take the total. Okay, so at t equals to 0, we have found that s is 3 meters. Okay, let's do the proper working substitution. 6 minus 9 over 3, that gives me 3 meters. Okay, and then at t equals to 3 seconds, 3, s will be 6 minus 9 over 3 plus 3. So 3 plus 3, then 9. 9 the 6. Okay, we get 4.5, so it's 4.5 meters. Okay, so your average displacement, okay, you take the final value, average velocity, not displacement. Okay, you take the final value, the final displacement minus the initial, the starting displacement, I and okay. Then you divide by the total time. Okay, so my final displacement is at 4.5. Okay, so displacement will be 4.5. Then my starting displacement is 3. So you minus 3. The difference of timing is 3 seconds. So 4.5 minus 3, then you divide by 3, you get 0.5 meters per second. Okay, after which you need to find the acceleration of P at t. So you are given the displacement. So s equals to 6 minus 9 over t plus 3. So to find velocity, you need to ds dt plus derivative. So this will give me, this is minus 1. So you get minus 9 minus 1 over t plus 3 whole thing squared. So this will simplify to 9 over t plus 3 whole thing squared. And then from velocity to acceleration, okay, you need to find dv dt. So there will be 9 times -2 over t plus 3 whole thing cubed. Okay, and you simplify this to be minus of 18 over t plus 3 whole thing cubed. Okay, and so at t equals to 3, acceleration will be minus 18 over 3 plus 3 whole thing cubed. And this will give me cube 18 over answer. You will get -1 over 12 meters per second squared. Okay, that's the unit for acceleration. Okay, so this is for try 3. Okay, let's move on to try 4. Okay, if you want to attempt the question yourself first, you can pause the video, and then from there you do, and then you can play the video again to find the answer or get the solution out. Okay. So we have particle P moving from a fixed point O, travels in a straight line, and velocity is given. T seconds after leaving O is given as that. Find the acceleration of P after 4 seconds. Okay, so first part, we have V equals to -10 plus 3t plus t squared. So you want to find acceleration. So acceleration is dv dt. So if you differentiate this, you get 3 plus 2t. So at t equals to 4, acceleration will be 3 plus 2 times 4. Okay, 3 plus 3 times 4. That will be 11 meters per second square. So in kinematics, units are very important. Okay, most of the time the questions given to us are in meters and seconds. Okay, so you can work. Please just take note if the question decides to change unit. So please write the units correctly. Okay, back part 2. Okay, displacement of P from O when P is instantaneously at rest. Okay, that's the keyword again here, instantaneously at rest. So these are, what this means is you are looking at V equals to 0. Okay, when is it instantaneously at rest? Okay, so here we don't have the time. Okay, so if we need to find displacement, okay, we need to integrate V because we are only given velocity. So if you want displacement, you need to integrate. But the problem is if you want to substitute your time value, which we don't have, you cannot find displacement. Okay, the other hint that's given to us is instantaneously at rest. Okay, so here, okay, when V equals to 0, okay, we will start V equals to 0 first to find out at which times P is rest. So we have t squared, let's just rearrange it as we write it out. T squared plus 3t minus 10 equals to 0. Factorize, you get t plus 5, t minus 2 equals to 0. And we know that t equals to 2. Okay, since t has to be bigger than 0. Okay, we don't have negative time, so t is 2. Okay, so we know that t will be instantaneously at rest at t equals to 2. Okay, so then let's calculate the displacement. So in order to get the displacement function, we need to integrate v with respect to t. So we are integrating -10 plus 3t plus t squared with respect to t. Okay, so if you integrate this, you get -10t plus 3 over 2 t squared plus 1/3 t cubed plus c. Okay, don't forget this is a indefinite integral. Okay, so you need to put the constant at the back plus c. Now here, when t equals to 2, so what we need to solve is we need to find out what the value of c is. Okay, so what is the value of c? The particle p moves from the fixed point O and travels in a straight line. Okay, so here there is this phrase here. It's t seconds after leaving O. Okay, and we know that O is a fixed point. Okay, so here what it means is that at t equals to 0, s is 0. Okay, so we can say when t equals to 0, s equals to 0, and hence we have, okay, so that means c is 0, okay? So this implies that c is 0, so therefore s will be negative 10t plus 3/2t squared plus 1/3 t cubed. Okay, so at t equals to 2, this is where we are calculating. My displacement will be negative 10 times 2 plus 3/2 times 4 plus 1/3 times 8. Okay, so if you press your calculator, 3/2 times 4 plus 1/3 times 8, then you take negative 20 plus answer, it should give me the answer as reflected. So you get negative 11 and 1/3 meters. Okay, you can leave it in 3SF, which should be minus 11.3 meters to 3SF. Okay, two more questions, try 5 and try 6. Okay, so we have a particle moving in a straight line, so that time t after leaving a fixed point O, its velocity is given as that. Find its initial acceleration. Okay, so you see the word initial again. So initial tells us that t equals to 0. Okay, and we want acceleration. We are given velocity v equals to at e to the power minus t over 2. So to find acceleration, we need to dv dt. Okay, differentiate velocity with respect to time. Okay, differentiate velocity with respect to time, so you get at and then multiplied by the power of the exponential function, which is minus half, that e to the power of minus t over 2. Okay, simplify this, you get minus 40 e to the power of minus t over 2. Right, so at t equals to 0, a will be minus 40 minus e to the power 0 divided by 2 is 0. So this is e to the power 0, which is actually 1. Okay, please take note, e to the power 0 is 1. Okay, so this is negative 40 meters per second squared. Okay, and then for part 2, okay, calculate to 2 decimal place is displacement from O when t equals to 4. Right? It is again t seconds after leaving fixed point O. So here we are also looking at t equals to 0, s will be 0. Okay, we are looking at displacement. So for s will be integrate v with respect to t. So we are going to integrate at e to the power of minus t over 2. Okay, with respect to t. All right. So for here, okay, so in order to integrate this, we need to take out half. So if you take out a negative half from here, from 80, you get minus 4, minus 160. Okay, so if we integrate this, you will get minus 160 e to the power minus t over 2, then plus a c. Okay, and we know that at t equals to 0, the displacement is 0. So 0 equals to minus 160 plus c. So c will be 160. Okay, so my S displacement formula would be minus 160 e to the power minus t over 2 plus 160. And when t at t equals to 4, we will have S equals to minus 160 e to the power minus 4 over 2 plus 160. So this, you just press your calculator. It's actually 100 minus 160 e to the power minus 2 plus 160. Okay, so minus 2 times negative 160 plus 160, you will get 138.346, and your answer to 2 decimal place 35 meters to 2 decimal place. And my last question for this. Okay, so in general, anything that they say time t after passing through O, you will know that when t is 0, your displacement is 0. Okay, now this question, the last question, passes origin with a speed of 10 meters per second. So let me just give you an overview what happens here. You have O at t equals to 0. We have a speed of 10 meters per second. Okay, and the acceleration is given as this. Calculate the velocity of particle. Oh, sorry, speed. I put in the wrong notation, v. Okay, calculate the velocity of particle when t equals to 2. So at 1, you want velocity, you integrate the acceleration. So we're integrating 3 minus 2t with respect to t. So this gives me 3t minus t squared plus c. Okay, it's minus 2 over 2, then t squared. So 2 over 2 is 1. All right, so at t equals to 0, b equals to 10. So therefore, c will be 10. And the velocity function will be 3t minus t squared plus 10. Okay, then at t equals to 2, v would be sub 2 in 3 times 2 minus 2 squared plus 10, and you will get 6 minus 4 plus 10. Answer is 12 meters per second. Okay, next, maximum velocity of the particle. Now, think of this as maximum value of v. Okay, when does maximum value of v occurs? Okay, this happens when dv dt equals to 0. It's a stationary point. Okay, and so which means we are looking at a equals to 0. Okay, so for maximum velocity, a equals to 0, and then you need to find the time. Okay, so a 0, so 3 minus 2t equals to 0, 2t equals to 3, t will be 3 over 2 seconds. So at t equals to 3 over 2 seconds, we use sub into the velocity formula, 3 over 2 minus 3 over 2 square plus 10. Okay, so you get 3 times 3 over 2 minus 3 over 2 square plus 10. So you get Here, you will get your answer to be 12 and 1/4 meters per second. Okay, as given in the answer. Okay, part 3, you're supposed to find the displacement of the particle when it is at rest. Okay, so there's a keyword at rest. Okay, so these are things that you need to pick up. V equals to 0. Okay, and then you need to find displacement. Okay, displacement is ES. Oh, sorry, displacement, you need to integrate the velocity. All right, so let's find out when is the particle at rest. Okay, at rest, velocity is 0. So when you solve, you get here 0 equals to 3t minus t squared plus 10. Okay, let's rearrange it. T squared minus 3t minus 10 equals to 0. And so you get t minus 5, t plus 2. Okay, t would be 5. Okay, because t is greater than 0. Okay, these are shortcuts that you can write. If you know that a value is already positive, so you can just put t greater than 0 and give the final answer. Okay, right. And then from there, we need to find the displacement of the particle. Okay, so in order to find displacement, you need to integrate 3t minus t squared plus 10. With respect to t, this gives me 3 over 2t squared minus 1/3 t cubed plus 10t plus c. Now everything is with reference to the fixed point O. So at t equals to 0, we will know that s has to be 0 as well. Okay, because your formula revolves about this point, a equals to 3 minus 2t. Okay, so every time I integrate differentiate, you are actually referencing from this fixed point. So displacement is 0. So when t equals to 0, s equals to 0. So my displacement formula is 3 over 2t squared minus 1/3 t cubed plus 10t. So at time equals to 5, we already calculated that time equals 5 when it's at rest. Okay, so s would be 3 over 2, 5 squared minus 1/3 5 cubed plus 10 times 5. Okay, so this one has a long list of numbers to key in. Okay, so you will end up with 45 and 5 over 6 meters. Okay, and then part 4, calculate the average speed during the first 6 seconds. Okay, so please take note the keyword is speed. So we need total distance. Okay, then you divide by total time. All right, so here we really need to understand what's going on here. All right, 5 seconds is at rest. So that means 5 seconds is really turning. Okay, and we know that the distance is 45 and 5 over 6. So at 5 seconds, let's draw this again. So we have a long line. We have O. Okay, at 5 seconds, okay, the particle is moving out. What do they want? They want the 6 seconds. We know the particle is going out and then it is turning. Okay, this is 45 and 5 over 6. All right, let's find out what is the displacement at 6 seconds, since we want average speed for 6 seconds. So at t equals to 6, my displacement is 3/2 times 6 squared minus 1/3 times 6 cubed plus 10 times 6. Okay, on back. Oh, 3/2 times 6 squared minus 1/3 times 6 cubed plus 16. Okay, the displacement here is 42 meters. So we know at t equals to 6, you are here at 42 meters. Okay, so between 5 seconds to 6 seconds, you need to calculate what is this distance. Okay, here. So your total distance, okay, you will take 45 and 5/6, add with the difference between the 5th second and the 6th second. Okay, we're not talking about total displacement. Here we are talking about total distance. Okay, because we are looking at speed. Okay, so please match the correct thing. You need the correct quantity. So here, where's your calculator? 45. So you get 149/3 meters, and therefore my average speed is total distance 149/3 divided by total time. We're looking at 6 seconds. So this divided by 6, it will give me 149/18, which turns out to be 8 and 5/18 meters per second. So that's all of the try questions that we have in this chapter. All right, then you can look at your homework questions and attempt it. We will meet the next lesson to go through the questions. Okay, bye-bye.